Good afternoon, everybody. This is Nick Zulfikar. Thank you for joining us on another webinar by Logisoft. My name is Nick Zulfikar. I'm the Director of Client Services here. With me is my colleague Ron Hussain, who's our Senior Most Technology Evangelist. Ron's going to be taking us through a very popular topic today, which is NCache Architecture. He's going to talk about different use cases as well as caching topologies, and some code samples, and show some of the other usages of NCache as well. So with that, I will turn it over to Ron. And if you have any questions, kindly type them in the questions box on the right-hand side of the screen. So Ron, kindly get started, please.
Yeah, sure. Thank you, Nick. Hi, everybody. My name is Ron, and I'll be your presenter for today's webinar. And as Nick suggested, the topic that we've chosen today is going to be NCache architecture. We'll talk about NCache, clustering details, how NCache cluster is optimized, how it works, what are the common use cases for NCache. And then we'll also talk about some of the caching topologies and their associated use cases. So this is an NCache webinar where we cover a lot of NCache related details. What are the common applications that can use NCache in an efficient manner, and then they can take charge of their any scalability or performance related bottlenecks that they may have. So assuming everything looks good, if you can see my screen, hear us fine, see us, please give us a confirmation and we'll quickly get started. So I hope everything looks good. Guys, please confirm.
I can see you fine. Well.
All right, so assuming everything looks good, so let's quickly get started with the presentation. First, I'll talk about some introductory slides about what exactly is scalability and what is the associated scalability problem that you can encounter in your application environments. Typically, we have, and this is going to be more focused towards .NET applications. So I'll talk about, I'll give .NET applications, examples from .NET application architectures. Typically, your application tiers are very scalable. You have ability to add more and more web servers or app servers if it's a web application or some Windows service respectively. You have ability to add as many servers as you need to, and you can distribute load between these application servers and their resources in a efficient and in an equal distribution manner. A typical example would be ASP.NET Web Form, where you have an ASP.NET web application deployed on an ASP.NET web server, in an IIS on a web server which is hosting that application. But you have ability to create a web form of multiple servers where you can add more and more resources, more and more web servers, and you can distribute your application load on those given servers. Similarly, within one web server, you have ability to add worker processes, and you can create a web garden. You can distribute load of the web servers. Resources would be utilized to the max potential, where you can put more and more load by having multiple instances of same application deployed on the same machine itself. That's called web garden. So your application tier scales out nicely. You can even scale up. Scaling up is usually not a problem, but scaling out, that's the main challenge, and your typical application tiers are pretty scalable. As a matter of fact, they're linearly scalable. So that's not the point of contention. The main point of contention is your data storage. All these application tiers, be it ASP.NET web application, it may have to talk to some backend data sources for the data related tasks, and then it may also have ASP.NET sessions or page outputs stored in a database. So that is the main source of contention. It's, first of all, database itself is not very fast. It's disk based. It's not in memory. There are concepts of caching, but that's not efficient in most of the cases. And on top of it, when your application load grows, database tends to choke down. It's not meant to handle huge transactional load from the application end. You can use database for storage purpose, and it's very good at it. But when it comes to handling extreme transactional processing, the XTP, it's not very good, and it can choke down. It can slow things down, and does not have capacity to handle the increased load that you're anticipating or you have from your application end. And you don't have ability to add more servers, so it's not something that you can scale out. You can scale it up, and there's a certain limit to that end as well. Eventually there would be a limit where you're not able to scale up as far as hardwares are concerned, hardware resources, and scaling out is not an option with database. It's a single source, and in some cases it's a single point of failure as well. You can use replication, but most importantly, it's slow and it's not scalable. And typically NoSQL databases are getting popular, but those NoSQL databases are not always an answer for the scalability problem. The main reason is you're not able to use them all the times in your application. NoSQL technologies such as we have a product called NASDB, which is actually a NoSQL database. It demands that you re-architecture your application and start using a NoSQL database and start replacing the existing relational database. So relational database, you need something which is used in combination to a relational database, and then it's something which takes care of all the performance related and scalability related issues. So assuming that your data storage is the main point of contention, it's a relational database or some file system or mainframe as well. This actually impacts your application tiers as well. Your applications would get slow response times. It could be expensive, costly to the end users as well, who may not want to wait for, let's say, even for 5 seconds for something which needs to be done. So you can have an actual impact on the business if your requests are queuing up and you don't have capacity to handle extreme amount of request load that you're expecting or that you already have on your application tier. So solution is very simple, and as part of our regular webinars where we talk about the scalability or scaling .NET apps with the help of distributed cache, we talk about NCache as a solution. So assuming that you consider using a distributed caching system like NCache in your environment, NCache, this is how it is deployed. It takes care of all the issues that we just discussed. So first of all, you can create a cache cluster, and your applications can start talking to this cache cluster, which is not just a single source, it's a team of servers. There are multiple servers basically which are going to have your cache repository handled, and these contribute towards request handling capacity for NCache. Typically you could create a cache on 2 to 3 caching servers, and based on your request load, if you see that these servers are being maxed out, you can add more servers. And nice thing about this caching tier is that your applications use this as well as it also uses the relational data source as well. So in combination to one another, your applications can simply use NCache in combination to a database where some of the data can be in NCache or all of data. It's entirely up to you how you architecture it. Typically we recommend that you should have most of your data cached, and 90% or 80% 90% of your traffic is through NCache, and in some cases you can have 100% of traffic with NCache, and then you can have some database providers here. But typically, assuming that you have most of your data in NCache, you would fetch data from the cache. If you find data from within NCache, you don't have to go to the database, and that's how you save your expensive trips to the database. You return control from this point, and if next request, you have to have some updates in the database, you can update the cache along with it. And if you don't find something here, you can always get it from here, find a null value, and then find it from the database and add it to the cache as well for the subsequent requests. So that's how your application can manage these sources. There are data consistencies and some synchronization features that you can also put in place, and on top of it you can also have data access layer logic built into NCache, where we can have some read-through and write-through providers become part of your caching tier, where this can be automated, where you only talk to NCache, and then NCache can in turn talk to database if an item is not found, where it can always get it from the database by calling your provider. read-through provider. And similarly for updates, it can update the cache as well as the data sources, again using your write-through provider, and right behind is an asynchronous approach of it. I'll see if I can spend some time towards the end around these object caching features. But in general, why distributed caching is more scalable and faster in comparison to database. First of all, it's in memory, so it's super fast in comparison. Unlike disk, unlike database, it's going to be stored. Everything is in memory as far as NCache storage is concerned. And on top of it, you have ability to create this cache on multiple servers. To start off, you can have 2 to 3 servers, and like I said, you can add more servers on the fly. And it's linearly scalable when it comes to handle more and more request load. You can start putting more load, and you see if your servers are being maxed out. Again, on the hardware side, you can introduce more servers on the fly, and that's the beauty of it. You don't even have to stop the cache or any of the clients which are connected to it. So dynamically, you can make changes to a running cache cluster. As far as deployment, typical deployment of NCache requires that you have Windows environments 2008, 2012, 2016. Only prereq for NCache is .NET 4.0. You can choose to have separate caching tier for NCache, and these clients could be either installations of NCache using libraries from within the installation resources, or you can use NuGet packages to connect to NCache. It could be any web app, .NET or Java, web services, server apps, which is seeing performance issues, contention issues, high availability, reliability issues. You can simply plug in NCache and start using for these use cases. I'll cover some use cases in a bit, but this is just to give you a general idea about the applications which can actually use NCache. Please let me know if there are any questions around the deployment architecture. NCache can be hosted on-prem, on the physical machines, as well as on VMs. You can also host it in cloud environments. It's fully available. Our preferred platform within cloud is Microsoft Azure, as well as AWS Cloud. But you can use any hosting provider where you have a physical or a virtual machine. Typically, in hosting providers, it's going to be virtual machine, but on-prem you can even have physical servers hosting NCache, and NCache fully works on those. So moving on, we have some NCache scalability numbers. I'm showing these numbers right here, but I'll show an extended form of these numbers comparing each caching topology of NCache as well. That's something we have lined up next. As far as scalability numbers are concerned, NCache, we've already discussed that it's very scalable. It allows you to add as many servers as you need to, and by adding more servers, you simply increase the capacity of how many requests, how many transactions per second you can handle. So with 2 servers, based on the hardware configuration that you have on the given service, these were the tests that we conducted with 1 kilobyte average object size and a simple web server kind of configuration box, not a high-end server, very regular configuration, and we were able to achieve about 32,000 writes per second and 50,000 reads per second with 2 servers. And we added 3rd server and 4th server until those servers maxed out on the hardware resources side, and then we added a 3rd server at that point and 4th server at that point. So from 2 to 4 servers, you can see the capacity almost doubled, 32 to 64,000 and 50,000 to 96,000. So that's the idea, that you can add more and more caching servers to accommodate all the increased load that you're anticipating from your end client. So you don't have to worry about it changing anything inside your application architecture. It's scalable and it's linearly scalable. You can add more servers and you will see the performance growth in a in improved linear manner. Some use cases for NCache. Typically, you should consider using NCache within all sort of applications. It could be your web application, trying to use ASP.NET web related caching, session state, view state, output. Similarly, you can use it for database caching. All the data which usually belong to the database and going to the database is usually slow. You can plan on using NCache for that as well. And then there are various ways you can use NCache. You can use it through direct API calls. That's what we cover under data caching. It could be a Windows service, it could be a backend workflow, it could be a web service, it could be a console app even. Depending upon what sort of application you have. It's a server app, it's a front-end web app, it could be a web service used by other web applications or regular applications. It's entirely up to you. The idea here is that any application which is seeing performance issues, scalability issues, and then you need some data reliability and high availability features as well, you should consider using NCache. So first mode of using NCache is through application data caching. This requires that you use NCache API calls directly into your application. I'll show you the APIs in a bit. And you can cache almost anything inside your application architecture. It could be your domain objects, collections, data sets, images, any sort of application related data can be cached using our data caching. And idea here is database is not very scalable, it's slow. You improve your performance by plugging in the data caching API, and then you can scale out, and it's also very reliable and very highly available as well. And there are chances where there are scenarios where you might want to cache your reference data, which is mostly read only. You should consider caching all your reference data here. And then there could be scenarios where you also plan on caching your transactional data which changes, and the frequency of change is slightly greater. So that should also be considered in caching, provided that you're reading that data more than once while you've cached it. And here is our API, a quick peek into the API. Right, so simply connect to the cache using the NCache initialization method. Get an object. If it's found, you don't have to go to the database. If it's not found, you simply get it from the database and add it to the cache. And this is how you add and update an item and then remove it. And towards the end, you can always call cache.dispose. Very simple, pretty intuitive, similar to HTTP runtime API, and gives you full control on how you want to use NCache inside your application. You control flow to the cache as well as to the database. And like I said, you can have some database synchronization features such as database dependencies. Any changes in the database are going to be invalidating the data in the cache, or in some cases refreshing the data, updating the data directly using our read through and write through providers. So that covers our first use case. Like I said, you can use it in web applications, web services, backend workflows, server applications, Windows services. Any sort of .NET and Java application can use our data caching model. Next use case is around web application side. You can use it in an ASP.NET or ASP.NET Core web application. Right, so again, data caching is overlapping here, so you can use data caching in that application as well. But specifically for ASP.NET side, we have a lot of features. To start off, we have session state caching, so you can use NCache for session caching, and all the options that are available for, such as inprog, that requires that you have sticky sessions. NCache does not need sticky session anymore. And then sticky session also mean sticky load balancing, and then single point of failure as well. If a web worker process goes down, you lose all your sessions. Then state server is a single server that you can use as a session option by default. NCache is again better than that, because NCache is distributed, cached here in comparison to a single server. That's a single point of failure, and it's also not very scalable. And then database is third option that you can also use by default. Database is again slow and not very scalable. So all the existing ASP.NET session state options are either slow, they're single point of failure, or they're not scalable. With NCache, you simply create a cache, plug in our provider on the code on the client end side without any code changes, and you can start using NCache for session state caching. It only takes 10 to 15 minutes to set this up, and I'm talking about complete installation configuration of NCache cache cluster as well as the application side settings. And with NCache, sessions are extremely fast because it's in memory. You can have multiple servers to host sessions, and your web servers become completely stateless because they're not storing any session data anymore. It exists in NCache, and NCache allows you to add more servers, so you can have linear improvements in the request handling capacity. And on top of it, we have topologies, which I'll cover in coming up, upcoming sections, where you can have replication turned on, and any session data on one server is actually replicated on another as well. If a server goes down, or you bring it down for maintenance yourself, the replica is automatically made available, and it's a very reliable data transactions for ASP.NET Session. And session is a kind of data that you wouldn't want to lose at any point in time. So assuming you need your data to be always available for mission critical applications, or even for public facing e-commerce applications, NCache session state gets the job done. It gives you all the benefits and everything without any code changes. And you can use it for web forms as well as for MVC. It's fully compatible. And one other thing, it's available in single site and multi-site flavor as well. For enterprise, it's available for multi-site as well. For open source and community versions, you have single site and I think some variation of multi-site as well. Then we have view state caching. That's pre-MVC for your ASP.NET web forms. We provide a view state provider as well. Typical web forms have view state, which gets constructed based on the controls widgets that you have in your web forms. It's never really stored on the server end. View state is actually sent to the client side, and that's why it's called a client-side state management. It's never really used on the client browser end, but it does become part of your request and response packets, and it's sent back to the browser, and that's where you can see the view state. And on postback, it again becomes part of your request packet, and then it's used on the server on the postback. So it's always used on the server side. That's where it's needed, but it's always sent back to the browser, and it becomes part of your request and response packets. The challenges with this default view state is heavy in size, because it's becoming part of all the web forms, and you can have a lot of user requests, and you can have a lot of web forms, and each web form, each request constitutes a lot of view state, and it could become heavy in size. Now this goes back to the browser. So first issue is your request and response packets become heavier, and each view state is bundled with your request and response packets. So this slows down your application requests, because you're dealing with more data which is traveling back and forth along with the request packets. Lighter the request and response packets, better the performance would be. But that's not the case with view state. And then a view state is also heavy on the bandwidth side. And specifically if you have hosted application in cloud, in Microsoft Azure or AWS cloud, this is going to be something which you pay in dollars. So this would be increased bandwidth utilization cost for your applications. So that's also not a preferred option. And then view state sent back to the browser. It has all the information for the web form controls. It's not very secure. So these are some of the issues with view state. With NCache, you simply plug in NCache view state provider. Again, it's a no code change option, and it stores view state on the server side. And this view state is always kept on the server. That's where it's needed. And a small token, a static size GUID, it's a GUID which is static in size, and it's encrypted as well, is sent back to the browser. So you deal with a static size of view state, which is a short string. So your request and response packets become lightweight. That improves your performance. Similarly, your bandwidth utilization costs, those go down, because you're not dealing with huge amount of view states. And then on the server side, because it's in a secure environment, it's the view state itself is secure. So you take care of all the issues with default view state options, and this is again a no code change option. And when you post back, you simply make a call to NCache and use that token to get the actual view state. So it's pretty optimized. A lot of our pre-MVC application deployments, web forms, are using view state, and it adds great value. Third important use case within an ASP.NET application could be the output caching, and this is for those scenarios. And by the way, this is also for ASP.NET Core, where we have response caching. We also have ASP.NET Core, ASP.NET Core Session State as well. That's another feature that you can use in ASP.NET Core as well. We have iDistribute cache provider, and then we also have our regular session state provider in ASP.NET Core. Now, output caching and response caching, this allows you to cache the static content within your application. There are scenarios where the pages within your application, MVC or web forms, views or web forms, you have a static content or entire page is static. So it requires that you execute your pages all the time, and specifically if there's a backend database involved. For example, you have product catalogs. For an e-commerce application that needs to be served for every single request to your web application. Now, for this use case, you have to execute that page, that request. It has to get some records from the database. That's another hop, and then you're processing those records and presenting as part of the response, HTTP response to your end users. What if that content is not changing? So with the NCache, it allows you to cache that content. So you can have a ready-made page output made available when you need it. So you don't have to re-execute, re-render those pages which are not changing. And this is done with the help of output caching provider. It could be done for an entire page, or it could be done for the portions within a page. For example, there are contents within the page which are changing, but a grid within a page which is not changing. So in that case, you can actually use the output caching just for that grid. So this helps improve performance, and it also saves the execution cost, and that's usually the resource cost, the hardware utilization cost, which is associated. You save expensive CPU cycles, and you improve performance in comparison to that. So this covers our ASP.NET, and then we also have, for ASP.NET Core, we also have iDistributed cache. All the methods of iDistributed cache you can plug in NCache, because that supports the .NET Core allows you to support the pluggable iDistributed cache provider, so NCache can be plugged in for ASP.NET Core provider as well. Please let me know if there are any questions. I know this is a lot of information, but there are specific webinars that we do for these features. For example, there's a webinar just for ASP.NET, and then there are scaling .NET apps, which covers mostly the data data caching use cases. So please let me know if there are any questions, and I'll be very happy to answer those for you. Third important use case is through runtime data sharing. Now, and this is more relevant for serverless apps, right? And for that, we have pub/sub model. For example, you have workflows on-prem or in cloud, or it could be microservices or app services. So microservices are usually instance-based application modules, which are independent in nature. They're loosely coupled. And talking to a database, that is a huge cost, or talking to or managing an implementation, or having an infrastructure to support data sharing or coordination between those serverless microservices. That's an expensive, and that's a complex challenge as well. So in order to overcome a requirement where you need to share data between your microservices, or between your workflows or server apps, or even if it could be for web apps, if you need to share data between your applications, and it could just be data, or it could be message sharing or information sharing, you can use a powerful pub/sub model. So with pub/sub, the publisher side can send messages to NCache, and then NCache can in turn transfer it to the subscribers. Publishers don't have to know about the subscribers, and similarly, subscribers don't have to know about the publishers. Publishers can also be subscribers, and subscribers can also be publishers, and vice versa. And this, keeps the very idea of serverless apps interacting with the pub/sub platform, which is also very loosely coupled in nature, and it's very efficient in terms of message sharing, event coordination, data sharing. So all those use cases can be managed between those serverless apps with the help of our data sharing. And then we have event notification based on the data that you already have in the cache. Going to the data sources is usually expensive, and then data sources sending notifications such as database SQL dependency or SQL event notifications. That's very slow and very bandwidth. It's very expensive on the bandwidth as well. It eats up your bandwidth. So with NCache, you can first of all add data to the cache, and then you can get data-related events out of NCache. And similarly, we have continuous query, which allows you to map a criteria, such as all the products under $100 mark. It would mark those products in NCache and then sends you events. All the subscribers can get events for that data set only. So any products any new product gets added, it gets updated or removed from the data set that you're interested in, you get notified about it. And then at that point, you might want to requery data from the cache and see what has been changed. So this covers our common use cases. I've spent some time ensuring that we go into every single detail. I hope it was straightforward. Please let me know if there are any questions around these, and we'll move forward towards the architecture.
Ron, we don't have any questions so far.
Got it. All right. So assuming everything looks good, I'm going to move on. First of all, we will talk about NCache architecture, the self-healing dynamic cluster of NCache, why it is so extensible, why how exactly it allows you to add and remove servers on the fly. So first of all, you can it's based on our own clustering protocol. It's not any third-party or Windows clustering. We call it dynamic cache cluster, It's 100% peer-to-peer architecture. There's no single point of failure. There's no master or slave or any majority rule. Every server independently participates in the cache cluster, and it has full, full authority within the cache cluster. So it independently participates, and it has all the view of the cache configurations as well. And with the help of this clustering protocol, it allows you to add or remove any servers from a running cache. You don't have to stop the cache or any of the clients which are running, which are connected to this cache. There's a connection failure support which is also built into the protocol. First of all, whenever a client, a worker process or a Windows service, which is an instance, is a client instance for NCache, connects to NCache, it does not need to know about all the servers upfront. It can only have IP of one server, and that's good enough. Once it's connected to that server, there is a lot of information which is shared to the client at that very time, that initialization time. Primarily, it's the cache topology that this cluster is running, because you can choose from many topologies. And then there are the membership map. What are the servers which are already running in the cache cluster? If there are 3 servers and you got connected to the 3rd server, it would provide you information about server number 2 and server number 1 as well. And that's the responsibility of the server where the connection was made. And based on the topology, clients would know of all the servers, and then they may open connections to all the servers as well, again dependent upon the topology. Assuming that they're working absolutely fine, and a server goes down, this is detected on the survivor server's end, and then this information is propagated to the clients at runtime, which are intelligent enough to understand this, and then they make a decision to fail over their connections and start using the survivor nodes. And this is completely seamless to your clients. It's built into the protocol. Even the backup of that server which just went down is made available automatically. And with the help of this, if there is an unplanned outage, you're completely covered, and NCache protocol will ensure that your application is up and running and it does not have any issues. And similarly, if a maintenance is planned, you can bring servers down, and you don't have to worry about the surviving nodes not having the data or clients having downtime. That's why it's highly available in 100% uptime cache scenario for your applications.
Ron, there's a question. Can NCache use joins?
All right, so we do support NCache object query language that allows you to have an SQL-like syntax. It's currently the basic SQL. It does not support joins, but it does have ability to tag items. Let me give you a quick example. For example, if you would like to search products, you can run an SQL-like query, which can go something like select products where product.price is greater than 10 and product.price is less than 100. But it would run the query with an expectation that you only need products from NCache. As far as joins use case is concerned, we typically recommend that you use tags. For example, if there are record sets which have to come from 2 different entities, you need to have the resulting entities have the corresponding tags attached to them. And then you use tag-based APIs, get by tag, and then you specify tags of both tables, both the record types, and then you get the result set which match the tags accordingly. So tag is a way to manage joins, but as far as join itself is concerned, that's not supported with OKIll.
Okay. Another question is, how long is the recovery time of the client application in case one of the cache server goes down?
All right, so it's instantaneous because we're using TCP/IP based sockets. So if a server goes down, this server, because there's a heartbeat going on, other servers check status message, and then are also sending data back and forth. So as soon as there is a detection, which is within a few milliseconds, it would start the recovery process, and that's a configurable time. By design, you can have 2 recovery tries if a server comes back, and that's to take care of temporary outages. There are scenarios where this connection breaks and then this gets restored as well. In that case, server is there, but it just had the connection broken. So with recovery, 2 configurable retries. If it comes back, they don't have to update the clients continue to work. But if within those 2 recovery retries, if this does not come back, they would consider that this is out of the sync, and then it would notify all the clients instantaneously. So based on this default 2 retries, it can take somewhere between 60 to 90 seconds in a max case scenario. Usually TCP/IP sockets give you a response right away. So as soon as the response is received, the surviving nodes make a decision and notify the clients. Yes. I hope that answered your question. So it's based on the TCP/IP sockets, and it's also the configurable number of retries, which you can tweak. You can reduce the number of retries or increase based on your preference. Any other questions before we move on?
There's a follow-up question. Is there a heartbeat feature between clients and servers, for example, with an environment with a firewall is involved?
Okay, that's a very good question. We have 2 kinds of heartbeat. We have a server-to-server heartbeat, which takes care of communication between server to server, and I've shared some details on how that works. Similarly, there's a client-to-server keep alive, because this socket is kept open throughout the scope of the application. So once you connect to NCache, you would stay connected and you would use the same socket throughout the time. So there could be a scenario where socket got broken and then you performed an operation, you get an exception, and then you can retry. And that retry can also be automatic. There's a configurable option for that. But there's a feature built into the client protocol where you can use a keep alive feature. So if a socket breaks, it would automatically reestablish it. So heartbeat is available between server to server and between client to server communication as well. All right, next section is our caching topologies. We have 4 caching topologies. We have mirrored, we have replicated, partitioned, and partitioned-replica caches. This topology is available only in enterprise, whereas other topologies are available in our open source as well as community versions. Since it's an architecture webinar, so I'll cover all topologies and their associated use cases. First topology that we have is mirrored cache. And with an assumption that data is of 2 kinds, you would have a reference data, which is more reads than writes, or you could have transactional data, where you have reads as well as writes. So I'll give you a perspective of what topology is recommended for what kind of use case as well. So with mirrored cache, let's talk about the architecture. First of all, we have 2 servers that you can set up, and they would always formulate an active-passive setup. All the clients connect to the active server. That's where your data exists. 1, 2, 3, 4. These are data elements. And then you have passive server just for the backup purposes. And this is done asynchronously. Idea here is that clients connect to active server, and that's where they read and write data from. So reads are applied on this server, writes are applied on this server, and whatever write operations are performed, clients actually return their control right away by updating this server 1. And then there's a background process, a background thread, which takes charge of the replication. There's a queue which actually replicates data to the backend. It's in sub-milliseconds delay, but it's done independently. The cost of replication is not incurred on these clients. So it's super fast for reads as well as for writes, because it's only reading and writing from one server, and that's where reference and transactional data requests are being handled. So this is good for reads, good for writes. It's very reliable as well, because if this server goes down, there is already a backup here. And within the protocol, we've already discussed that these servers, the client servers, are intelligent. Once they detect that server 1 is no more part and server 2 becomes activated automatically, and these clients start using server 2 and stop using server 1. So they fail over the connections, seamless to your application users. So it's done instantaneously and based on the protocol automatically. So there's no data loss, no application downtime, and your subsequent requests are served by server 2 without any issues. Now this topology is, like I said, is very good for reads and writes. It's very scalable, very reliable. The only downside is that it's not very scalable, because you only have 2 servers in active passive configuration and only 1 is active. So you have a capacity of only 1 server. As a matter of fact, I'll show you the benchmark numbers, and I'll keep those open and compare different topologies while I'm presenting. So these were the same tests conducted for each caching topology that I had shown you earlier. You can see the read and writes per second capacity for mirrored cache, 26,000 reads and about 20,000 writes per second. And let's talk about replicated, the next topology. And this topology, this is slightly better than mirrored, where we can have multiple servers, more than 2. All servers are going to be active, so there's no passive node. But idea here is that each server has an entire copy of cache. So whatever data that you have on server 1 are copies on server 2 and vice versa. You can have third or fourth server as well, and with the same understanding that you would have copy of cache on server 3 and server 4 as well. Now, having multiple copies, you can also, this topology automatically distributes the client connections between the available servers, number of servers. If you have, say, 6 worker processes using NCache, 3 would connect to server 1 and 3 would connect to server 2. And this is done automatically within the protocol. First client instance connects to server 1 and it checks if server 2 does not have any clients. Second instance would automatically connect to server 2. So it keeps a connection balancing logic inside the protocol, and this is also built into the protocol. The mode of replication is synchronous for this, so whatever adds or updates are made on server 1, they're in sync applied on server 2. And by sync I mean clients would update the active and then also updates the backup, or the rest of the servers. It's not really a backup, the other servers are also active, but since there's a copy, they would also update all copies. And this can be expensive based on number of servers that you have, but this makes sure that you have everything in consistent manner updated on all servers. But reads are local to the server where they are connected. So reads are super fast, and more servers mean more reading copies and reading capacity out of NCache. Now, this topology is very reliable as well. If server 1 ever goes down, you have these clients just failing over to server 2, and if server 2 goes down, you have these clients failing over to server 1. And similarly, if you have third server, similarly clients would be divided between 3 servers. Each server would have a copy, and a sync update model is utilized. And as far as performance is concerned and use case is concerned, this topology is very good for reads, not that recommended for writes because of sync updates, and it's very reliable as well. Again, recommended for smaller configurations and more reads than writes scenario. And here is a benchmark result, where we have 1 to 2 node, reads capacity is increasing linearly, but writes capacity is going down because you have more hops to update in sync while client is waiting for that operation to be completed. If it fails in between, the whole operation is rolled back automatically. That's the architecture of the topology. Now, third and fourth topologies are going to be are very scalable and very performance centric. We have partition cache. In this, we have data distributed in the form of partitions. Some data goes on server 1 and some data goes on server 2. And this is done automatically. There's a distribution algorithm. A map is sent back to the clients, and these client applications automatically distribute data between the available servers. They calculate a hash against a key, and there's an intelligent hash algorithm which maps those keys onto the given servers. So you would always have a distribution of data between the available server nodes. So clients are the ones who are distributing, so they know where data exists. So reads and writes are extremely fast in this topology. In this, data is automatically partitioned. So partition of server data on server 1 and partition of data on server 2. Clients open connections to all the servers because they may need some data from server 1 and some data from server 2. And reads are very fast, local to the server. As far as performance notation is concerned, it's always going to be O1 notation for performance. So super fast performance for reads and super fast performance for writes. On top of it, they're pooling the memory resources and request handling capacity of all these servers together. So more servers mean more request handling capacity out of NCache. So if you add a third or fourth server, you simply increase the capacity by that factor. So reads and writes capacity would increase in a linear manner if you keep on adding more servers. So only downside of this topology is it does not have any backup. Other than for performance-centric scenarios, for good performance of reads, good performance for writes, and for linear scalability for reads and writes, this is a very good option. For reliability, if a server 1 goes down, you lose that partition. And you have to come up with some way of reconstructing that data from the backend data source. If that's the architecture, or that's the demand of your use case, you can pick this topology as well. You have to go back to the database and push that data into NCache. Otherwise, you would get null values for the data if a server goes down. And these are our performance benchmark numbers. You can see a linear improvement as you add number of servers in this caching topology. Pretty linear graph for reads per second and writes per second as well. Now, please let me know if there are any questions. This completes our 3 caching topologies. Now, I'm going to focus on our most popular topology. It's called Partitioned-Replica cache. Now, this topology comes with all the benefits of partition cache, and only downside of partition cache was to have the reliability problem. There are no backups if a server goes down, so maintenance becomes an issue, and if an outage on a given server comes, you lose the data. So this takes care of that issue as well, with all the benefits. Now, this topology, first of all, it's going to have 2 partitions. Overall architecture is similar, with one exception that we have one server maintaining 2 backups. two partitions. One is active data partition where clients are connected, and the other is a passive replica partition of another server. You can see server 1 has item number 1 and 2. It's having a backup on server 2. Similarly, item number 3 and 4 on server 2, the active partition where clients are connected, and it has a passive replica partition on server 2. These are passive backups. These are not active. Clients don't use it until a server goes down, but these actives are updating them. And then you have option of both sync and async replicas. In sync, client updates the active and updates the backup, and only then that operation is completed. In async, client updates the active, returns, it's fast, and then behind the scenes NCache updates the backup, and that's done all instantaneously as well in some milliseconds. And these are created automatically, by the way. You just create a cache topology and specify the number of servers, and based on that, the partitions would automatically be created. The backups would automatically be formulated, and the cache cluster would obey the laws of that cache topology. Now, you get reads and writes performance, you add more servers, you get more scalability, and on top of it, if this server goes down, it has a backup on server 2, so this becomes activated automatically. So this automatically becomes activated, and you start using the backup without any issues. So there's no data loss, no application downtime. Here's a comparison of these two topologies. Similarly, you can have 3 servers as well. So in this form, you have 2 servers, and then you have 3 servers. So 1's active, backup on 2, server 2 is active, backup on 3, and server 3 is active, backup on 1. So in a round robin fashion, you have each server maintaining its backup on another server, and it does not have any downtime by virtue of this. If a server, let's take an example where server 1 goes down, the backup of server 1 is on server 2, this becomes activated. Now there are 2 servers, but it needs to formulate this setup right here. In this, we have lost backup of server 3 because server 1 is down, and server 2 has a partial backup now because it also has backup of this. So this, as soon as it becomes activated, clients start using it, so there's no interruption on the client end, but this starts merging into the actives of other surviving nodes. So some data would go to server 2 and some data would go to server 3, and server 3 would formulate a new backup on server 2, and server 2 would complete its backup. So that's how it would heal itself and formulate a healthy 2 node, and this is completely seamless to your end users. Behind the scenes, there's a process of state transfer which takes charge of this, and it gets completed based on the data that you have, and it reformulates a healthy 2 node partition if there was a third server which just went down. So this is our most popular topology. Over 90% of clients use this for ASP.NET sessions, for view state, for output caching, and also for data caching. And I would personally recommend that you consider this once you're testing with NCache. And this is the performance benchmarks. This gives you the best of both worlds. Very good performance for reads. Reads are comparable with replicated as well as for partition, and very good performance for writes as well. Better than replicated, a lot better. Comparable with partition, but partitioning does not have backup. This has backup, so this is more recommended. And this is the same topology with async replicas, with sync replicas, where sync performance impacts the writes capacity, but it's still growing with a factor, and you can see the reads. So this is the most recommended one, partition replica with the async options. Please let me know if there are any questions. Otherwise, I'll move on to our client cache and 2 more features that I need to cover. Assuming we're good, we have next topology, which is called client cache within the architecture. This is also a very good feature for improving your performance. It allows you to, first of all, create a local cache. This could be any caching topology, and it's connected to your applications, and it's saving your trips to the database already, which is an expensive source. Now, client cache further saves your trips across the networks. It saves your network trips to this cache right here. So you simply turn on this feature, set up a client cache through management tools or PowerShell or command line tools, and it is a subset of the data that you have in the server cache. For example, you had 10,000 items here. You fetch only 100 of those items. 100 items would automatically be brought into the client cache. And idea here is that you keep data closer to your application, similar to L1, L2 cache in hardware. Now this cache is filled automatically, and it's utilized automatically. You keep on using the server cache. Behind the scene, it gets utilized. If data is found in the client cache, you don't have to go to the server cache at all. You get it from within the application box, and by keeping it closer, you save your expensive trips, and that improves your performance. And nice thing about NCache client cache is that it's actually a very synchronized, a fully synchronized without any code changes, a synchronized cache solution. So any changes that you make in the client cache are propagated in the server cache, and any changes that you make here, these are propagated back into the client cache as well. So it's fully synchronized, two-way synchronization is going on. So all the data that you have in the client cache is not stale at all, and NCache manages this. And on top of it, you can also choose to be client cache to be in proc in nature, which further saves serialization and inter-process communication overhead. So that really helps in terms of improving performance. And this is something which is just a plug and play option. You simply set it up and start using it. The goal here is that you should have more reads than writes. The use case for this is over 70% reads than writes. Primarily because if data is not changing, only then you would benefit. If data is changing, you'll be busy changing it here and in the server cache, so that would just impact the performance, negatively impact performance. So for more reads than writes, this is a very good pick. And last segment within this architectural webinar is our WAN replication, multi-data center support. Please let me know if there are any questions so far in all the existing caching topologies. I'll quickly cover WAN replication and then show you how to quickly set up NCache if time permits. Otherwise, we'll conclude it. Assuming, please let me know if there are any questions.
Yeah, I have a couple of questions here. Ron, how does a client cache ensure syncing? What is implemented in the backend?
All right, so basically we have a DB sync dependency that allows you to sync items between two different caches. So that's what we've implemented, and access to the cache is our read through and write through. Basically, that's the way we update and fetch data. And then there's an event propagation system with the help of DB sync dependency. That's an internal feature, and that's exposed to within the API as well. So you might want to use it directly as well. So if there are two caches, you want to sync data between those two caches where change in data data in cache 1 can propagate a change in the data in cache 2 as well. So that's the feature which we're using behind the scenes.
Okay. Another question is there any way to know for NCache that a row got inserted into the database? Is there any replication from SQL Server to NCache?
There is. We have a SQL dependency feature. By default, it actually allows you to set up a relationship between row in the database and the records in NCache. And any change in the database would automatically remove the records from NCache. But we did discuss data access layer providers. We can use read-through handler to automatically invoke your read-through with ease resync flag. There's a resyncing flag. If you turn it on and with an understanding that you have SQL dependency or any kind of expiration, removing an item, instead of removing it would just pass on control to your data access layer provider, and you can simply resync that data. Make a query within the code yourself. That code gets registered with NCache, and NCache would call it automatically each time an item expires because of SQL dependency or based on time-based expirations. And that row from the database can be added to the cache based on your read-through handler. So this gives you 100% synchronization with NCache, and that's how you would achieve it. We have WAN replication. You can use a bridge, and you can have two sites synced completely within your environment. You could have a DR site or active passive setup. Typically, you have an active site where all your clients and your web servers and databases are existing, and then you have a backup site across the WAN. So if you want to have cache to be backed up, you can use active passive with the help of bridge. Bridge is a queue. It simply allows you to have async replication, so replication cost is not incurred on the clients. You simply propagate the data to the target site through bridge, and this is done asynchronously, and bridge itself is backed up with an active passive queue. And similarly, you can have active sites. Both data centers can be active. Typically, you have clients facing in, let's say, London region, and then you have a site in New York region. They may have their own databases, so you might want to have their own copies of cache as well. And if there is a scenario where these traffics can use data from each other, from sites within each other, you could have this site transferring data to the New York site, and New York site can transfer data to London site. And this can be done with the help of active bridge. Again, this is part of the same product. It's part of our enterprise offering, and you can utilize it by just configuring it. This is our API. Typically, you would simply let me give you a quick overview of NCache configuration and NCache management tool. You would simply download NCache product from our website, install it, and then we have command line tools as well as PowerShell tools. And as a matter of fact, we have a management tool as well. And you can simply create a clustered cache and start playing around with it. Let's name the cache demo cache. Partitioned-Replica is our topology, async replica replication option. I'll go ahead with demo 1 as demo 2 and demo 2 as my 2 servers. And then I'll show you TCP IP port for communication. Keep everything default. Evictions can be turned on. If cache becomes full, you can automatically remove some data to make room for the new data. And that's it. That's how simple it is to configure NCache. And then I'll show you my box as a client. Alright, I think I can use 1 or 2 that can be acting as a client. There you go. And I can start and test this cache cluster. So that's how easy it is. You download the product, install it on your servers and on the clients, then create a server cache on 2 servers or 3, and then you add client nodes and start and test this cache cluster. And then there are a lot of sample applications which come installed with NCache. For example, we have within NCache installation sample applications. Right here we have .NET and .NET Core samples. So basic operations, that's one sample. Session caching, and alongside that you can use NCache for entity framework with RNA code changes and code changes options are available. Entity framework core, you can use extension methods to cache. Similarly, for nhibernate, NCache can be used as a second level cache. For SignalR, NCache can be used as a backplane. Alongside that, we've already covered session state, object caching, and different use cases around that. So this cache has been configured. It's running. I'll quickly run a stress testing tool application and show you that it gets utilized and gets activity load from the client side. And you can see one client is already connected, and you can see the request load coming in, and you can see the same request load on the servers as well. So this shows that you can use both servers automatically, and there are backups of each server maintained in the replica partitions as well. And here is a monitoring tool which is showing you some insight into the request capacity, CPU graph, size, network graph, memory graph, and some report views as well. So this completes our webinar today as far as technical portion is concerned. Please let me know if there are any questions. Otherwise, I'll hand it over to Nick.
Yes, I do have a couple questions. What is the best practice for maintaining the NCache server, updates, reboots, monitoring, etc.?
All right, so like I said, NCache allows you to simply add more servers on the fly. For example, I can add another server at runtime, and similarly it allows you to remove servers on the fly as well. Well, it's running a trial, but it would still be added. Typically we recommend that you first of all stop cache, and there's a graceful stop mechanism as well that allows you to stop the client activity. So you can perform that, and then you simply remove it from the cache or just keep it stopped, and then perform the maintenance, restart it, and then there are delayed restart features as well. Auto start allows you to start a server once the patching has been done. So you, based on your experience, you can restart that server and it will automatically join the cache cluster. So that's pretty much it. It allows you to perform maintenance. We have customers who perform maintenance on weekly basis. There are customers who perform maintenance on bi-weekly basis, and then there are monthly maintenances as well. So this is something where NCache is pretty mature. It has features which which actually take care of all the safe sides for a server that needs to be brought down. And typically it's a graceful stop that you need to take into account.
Okay. Another question regarding read-through, write-through. Is it possible to configure multiple read-throughs, maybe one for a database and one for some files?
Absolutely. You simply implement this provider from here. You need to stop the cache, and then you add a provider. You can provide different providers, and there's no limit to how many providers you have. There could be a provider for a relational data source. There could be NoSQL providers as well, a file system-based provider, and could even call a web service as well. So it's very flexible. It's a .NET code. It's a library that and it has a bunch of methods that you override, and within those methods, it's completely flexible on what logic that you need to introduce. A working .NET code can be used talking to any data source as a read-through provider, and you can implement multiple of these.
Okay, thank you. Guys, please let me know if there are any further questions. You can always contact us via support@alachisoft.com for any technical questions that you may have, and any other non-technical questions, you can reach us at sales@alachisoft.com. Just a reminder that you can download the open source community edition or the enterprise edition from our website. It's alachisoft.com. Try it out. We have a free 30-day trial version available of enterprise edition that you can use. I don't see any other questions, so I'd like to thank everybody for joining us today, and thank you, Ron, for taking time off, and we'll hope to see you again next time. Thank you.
Thank you very much, guys. Thank you. Take care. Bye-bye.